everyone, my name is Deepti Mittal. In this video lecture, we were studying database design. So up till now, we have completed almost all the topics which are required for studying database design. Initially, we started with keys, then we covered closures and canonical covers, then decomposition, higher normal forms, and decomposition of tables into higher normal form. In this order, we have completed almost all the topics required to study database design. So in this particular video lecture, we are going to study some previous year questions which are asked in GATE Computer Science examination and other examination, so that we can get a clarification what we have studied till now and how to apply all the concepts. So guys, if any one of you are having some doubts, so just refer all the videos again, or the specific video or the part in which you are getting some doubt. Or for some specific doubt, you can refer the books. I have already mentioned the books which are good for these topics. So let us start with some questions.
Check out the link below for free GATE course, more than 200 videos along with this video, doubt sessions, previous paper, more than 250 quiz from Gradeup.
Okay, this is GATE CS 2006 question. It was asked for 2 marks. Here we are provided with a relation R with 5 attributes V, W, X, Y and Z. Then we are given a functional dependency set and it is asked what are the candidate keys for relation R. We are provided with 4 options. So instead of calculating all the candidate keys, just check for the existing options. So let us start. Here attributes are V, W, X, Y and Z and the given functional dependency set. The first rule of finding candidate key was, if a particular attribute is not present in determiner part, that should be the part of our candidate key. If you observe here, W, Z and V are the part of our determiner set. So we are left with attributes X and Y. Then what we can say about X and Y? X and Y should occur in our candidate key. If I am going to calculate closure of X and Y, you observe what I am going to get is X and Y, that is the trivial thing. And can you see there is no other attribute which we can determine using X and Y. So X and Y cannot serve as candidate key. We have to take some extra attribute. Let us take V. So calculate the closure for V, X and Y. What we are getting? V, X and Y. That is the trivial thing due to trivial dependency. You know about this thing. We have discussed it in functional dependency lecture. Now you can observe V and Y can determine W and W and X can determine Z. So what we observe, V, X and Y can determine all the attributes of R. Then it can serve as candidate key. Here option B is saying V, X, Y. So the answer is option B. Notice one more thing, that we are given option C as V, W, X, Y. Definitely if V, X, Y can determine all the attributes, then V, W, X, Y can also determine all the attributes. So you can also say why we are not taking this option as candidate key. If you remember, I have told you that candidate key should be minimal. No other proper subset of candidate key should determine all the attributes. So this cannot serve as candidate key. Yes, it is super key, but not candidate key. Now you are clear with candidate key concept. In this manner, we can solve all the questions which are related to candidate key. Almost the same concept is asked when candidate key is asked. So now let us move towards next concept.
Subscribe to our channel and press the bell icon to never miss any update from Gradeup.
So the next concept is functional dependency and attribute closure. If you observe, we are given functional dependency set and it is asked which of the following option is false. Here some attribute closures are calculated and it is asked which of the following is false. So we will take one by one all the options. We will check for each and every option. Whatever is false, we can easily catch this thing. So first thing is closure of CF. The trivial thing which this particular C and F is going to have is C, F. Now observe the functional dependency set. F can determine E. So E is also added to it. Now If you observe, this F can determine E. Now we have C, F and E. Also E. This particular C can determine G. Now we have G here. Then this G determines A. We have A here. And this A and F can determine D. So we have D here. If we observe, option A is same as the attribute set or attribute closure set we have calculated. So it is not false. It is carrying A, C, D, E, F and G. Yes. So this option is correct. Now check for BG. What BG can contain trivially? Guys, I have told you this thing very many times. So it is clear to you now. This is going to carry BG and all the other attributes which are obtained by B and G. So if you observe, there is a functional dependency, G implies A, then it will gonna carry A also. Also, A and B can determine C and D due to first functional dependency. So if you observe, here it can determine A, B, C, D, G. Now check for other functional dependencies which it can carry. This C can determine G, but G is also already the part of this thing. Also you can see, no other thing you can calculate by using these attributes. So this is the function, this is the attribute closure for BG and it is also true. Now calculate for AF. I'm not gonna explain this thing in that much detail. You can observe on your own. I'm gonna write it. A and F. F can determine E, and then A and F can determine D, and D and E can determine F. That is the trivial thing. Then we are having A, F, E, D. Due to F we are having E. Okay, that's all. That's all it can calculate. No other attribute it can determine. So if you observe here, it is also determine C, which is not possible to determine because you cannot determine C using A and F. So option C is false. Okay. So what is the answer here? Option C. In this manner, we have calculated attribute closure many times. If it is asked, you can easily apply the concept of attribute closure for finding candidate keys as well as the questions which are of this type, and you can use the concept in the similar manner. This is the only thing which they are going to ask. They will not ask something very new. They will ask the concept in this manner only. So be confident while solving the questions. So this particular question, it was asked in GATE CS 2005 and it is related to functional dependency set closure. I have told you that closure you can calculate for two things. First for attribute and second for functional dependency. So observe, here are given, they are given us a particular set of functional dependencies and A, B, C, D are the attributes. It is asked which of the following functional dependency is not implied by the above set. So there are two ways of doing this particular question. First, you can calculate the canonical set, that is closure set for functional dependency, that you have to find all the functional dependencies related to this functional dependency. But that procedure is quite time consuming. We can use second option, that is we are provided with options. We will check for each and every option which is not implied. We can simply mark that. So start with option A. It is given CD. It is asked whether CD implies AC or not. So we will calculate CD closure. What CD determines trivially is C and D, and you can easily observe CD can determine E also. Okay, what we are having C, D and E can determine A. So CD can determine, according to this, CD can determine A, C. So this functional dependency is implied by the given set. Now check for BD closure. Tell me what BD closure is going to have. Tell me. First is B and D. Then according to B and D, we are going to have some more attributes. Say which are the attributes which are going to have no other attribute. You cannot get anything from B and D. C, we cannot determine alone anything, D alone cannot determine anything, and B and D combinedly cannot determine anything. So we cannot say that BD implies CD. It is false. Let us check for some other options. BC implies CD or not. What B can implies D. Yes, this functional dependency will exist. Surely it will exist. Now check for AC. What AC is going to have? A, C, and A can determine B also, and B can determine D. Yes, this also exists now. AC implies BC. So what is the option here which is correct? That is B. Because this particular functional dependency is not implied by the given set. Let us move towards the next concept and the next question. Now we will discuss something about lossless decomposition. We have discussed a good number of questions, how to find decomposition and how to find the highest normal form. Let us take a theory question. It was asked in GATE CS 2002. So I will read, you read along with me. Relation R is decomposed using set of functional dependency F, that is a relation R is having functional dependency set F, and relation S is decomposed using set of functional dependency G, that is set of functional dependency for relation S is G. It is given that one of the decomposition is BCNF and other is 3NF, that is the decomposition which is made of R or S, one of them is BCNF and another is 3NF. But it is not known which is which, that is we are not aware that the decomposition of relation R is BCNF or 3NF or S is BCNF or 3NF. We are not aware of that thing, but one thing is sure that one is BCNF and another is 3NF. To make a guaranteed identification, which of the following tests should be used on decomposition? So we have to determine which of the following relation is in which normal form. So which test we should carry? First is given dependency preservation. It is asked that we have to check for dependency preservation. Yes, it may work because sometimes BCNF relation does not satisfy dependency preservation. But this thing is sometimes, not always. This thing is not satisfied for each and every relation. So we cannot take this thing for testing. Second is lossless join. We cannot take this test because both 3NF and BCNF both satisfy lossless decomposition. It is possible to decompose each and every relation into BCNF or 3NF while decomposition is lossless. So this test will not identify or differentiate these two things. Next is BCNF definition. If we test for BCNF definition, definitely this thing is going to work. You will ask why? Because the relation whichever is in 3NF will not satisfy BCNF definition, but the relation which is in BCNF is going to satisfy BCNF definition. Then we can easily differentiate which one is which. So what I have, which one is correct is C option. Let us discuss about D also, 3NF definition. We cannot use 3NF definition, and you guys are aware why we cannot use 3NF definition. Tell me. Yes, this is the reason that both BCNF and 3NF satisfies 3NF definition. So there is no meaning in testing 3NF definition to differentiate these two relations and these two decomposition. So the correct option is BCNF definition, that is option C here. This concept was about differentiating BCNF and 3NF, and you can learn one more thing. If a relation is in BCNF, it satisfies 3NF. If it is in 3NF, it already satisfies 2NF, and if it is in 2NF, it satisfies 1NF, and 1NF is the default normal form of our database design. Let us move to the next question. It is asked in GATE CS 2008 for 2 marks. So here we are provided with a relation R having 7 attributes. You can observe the attributes are A, B, C, D, E, P and G. And same thing, we are provided with a functional dependency set. Observe here, we are provided with 5 functional dependency. It is asked which highest normal form or which normal form is satisfied by this particular relation. So instead of going with options, we should calculate which normal form is satisfied by this relation. So if you remember, if you have to calculate the highest normal form, first thing you have to calculate the candidate key. Guys, this is the reason I told you that each and every concept is interrelated. You cannot manage with skipping one or two concepts. You have to study each and every concept very dedicatively or very thoroughly. So calculate the candidate key. This is, I think, most trivial thing which we are doing from our second video lecture. We are very fluent in this up till now. So what is the candidate key? If you observe here is A and B, because AB can determine all the attributes. AB can determine AB trivially, CD, then C can determine E, and D can determine P, and P can determine C, and B can determine G. These all are the attributes, and AB is serving as candidate key here. So tell me, this relation is in which higher normal form? If you observe, you can clearly observe here is existing a particular functional dependency, B implies C. B is proper subset of candidate key, and G is non-prime. So it is partial dependency. So this relation is not in 2NF. If a particular relation or the functional dependency set is carrying partial dependencies, then that relation is not in second normal form. So the highest normal form of this relation is first normal form. So which option is correct here? Option B. Now let us move towards next concept. We have studied decomposition, normal forms. Let us discuss something by merging these two concepts, that is decomposition of relations into higher normal form. And the higher normal form, if I told something that higher normal form, so if we are discussing single valued functional dependencies, then what is the highest normal form? BCNF. So in this particular relation, we are provided our ABCD is a relation which of the following does not have a lossless dependency preserving decomposition. It is not mentioned which decomposition. So we have to take the highest decomposition, highest normal form, which is BCNF. So it is something like solving 4 questions of dependency preserving decomposition. Suppose A, I will let it as functional dependency set F1. Suppose our relation is having now functional dependency set F1. So same thing, what is the candidate key here? Yes, candidate key is A. Now tell me the highest normal form which is satisfied by this particular relation. If you observe, one thing you can see here, candidate key is A. That is simple candidate key. Compound candidate key is not present. So there is no concept of something like AB, that is proper subset of candidate key. So this relation is always in 2NF. Now check for 3NF. What 3NF says, there should not be any functional dependency like non-prime attribute determines non-prime attribute. But it is having functional dependency something like that, that is B implies C and B implies D. You know that you can split these two things. So this relation is in 2NF but not 3NF. So let us divide this particular relation into 3NF. The same way we have studied in our last video lecture, we will gonna do the same thing. The problem is occurring due to B, then we are gonna separate all the attributes which are determined by B into separate relation. Here what is the B closure? If you observe, that is B, C and D. So B, C and D are taken into one another relation and we are left with A, but we have to keep at least one attribute common between them to satisfy the property of lossless decomposition. So what we can take common? The attribute which is serving as candidate key for other relation, that is B. So now divide the functional dependency set. A implies B and B implies CD. Here candidate key is A, here candidate key is B. So you can say this is in BCNF and this is also in BCNF. So option A is not the right choice because it is possible to divide this particular relation R with the given functional dependency set into lossless dependency preserving highest normal form. Let us check for B, option B. We are provided with 3 functional dependencies, so option A is correct. Now, if you observe here, we are provided with 3 functional dependencies. So, tell me the candidate key here. Same, A is serving as candidate key. Now, if we are having simple candidate key, then relation is in 2NF. But it is not in 3NF. You can easily observe why this relation is not in 3NF. Due to B implies C and C implies D. Here non-prime attribute determining non-prime attribute. Non-prime attribute determining non-prime attribute. We will divide this particular relation the same way we have done above. That is AB and then B, C, D. Now this is having functional dependency A implies B, and this is having B implies C and C implies D. This is in BCNF clearly. We have done the same thing with option A. But if you observe the case with B, C and D, B is serving as candidate key. But we are having functional dependency C implies D, that is non-prime attribute determining non-prime attribute. Now it is in 2NF but not in 3NF. So again we have to divide it into 3NF. So let us take B, C and CD separated. Then B implies C and C implies D. Now you can clearly observe it is also in BCNF. This is also in BCNF. And decomposition is lossless because here if you observe C is serving as candidate key for this part and B is serving as candidate key for this part. So decomposition is lossless and all the dependencies are preserved. Okay. So option B is also possible to decompose into BCNF while preserving all the dependencies, and decomposition is lossless. Now let us discuss about option C. We are having 2 functional dependencies, AB implies C and C implies AD. Let us calculate the candidate key, the same thing which we are doing up till now. So the candidate key for this particular relation would be AB and BC. So if you observe here, C is determining D and C is proper subset of candidate key and D is a non-prime attribute. So this relation is in 1NF but not in 2NF because there exists a partial functional dependency. So we have to decompose it into second normal form. The same thing we are gonna do, we will calculate attribute closure for C and we will separate all the attributes which are determined by C. Calculate attribute closure for C, that is A, C and D. I am going to separate A, C and D when I will be left with B only. But we have to take something in common. What I am going to take? Let's take. We have to take that attribute which is serving as candidate key for the other part. So C is serving as candidate key here. I have taken C, ACD and BC. So the functional dependency which we are going to have here is C implies AD, and for this relation we cannot have any functional dependency because BC there is no functional dependency for B and C. So you will say you can add A, B and C. Let us say I have added A, B and C to modify it. Then what functional dependencies I am going to have? AB implies C and C implies A. Now, if you clearly observe, it is the case where we have discussed that it is in 3NF but not possible to decompose into BCNF. Not possible because candidate keys here will be AB and AC, and it is not possible to decompose into BCNF while preserving all the dependencies. So what is the answer here? It's option C. If you discuss about option D, it is having only one functional dependency, that is A implies B, C, D. A is serving as candidate key. There is no dilemma, there is no confusion. This relation is already in BCNF. So why we need to decompose it? There is no need of decomposition. So what is the answer here? That is option C. So guys, till now we have covered all the concepts of database design. We have tried to cover all the concepts and taken 2 or 3 examples for each and every concept. So still if you have some doubts, you can refer the videos again, and still some doubts, then you can refer the books. I have mentioned the name of books for each and every topic in my starting videos. So if you have some doubt, just refer it. Thank you guys. Stay updated for more videos. Thank you and all the best for your future.